Hello and welcome to Mathematics Illuminated, where I shed light on any and all math topics from simple to advanced in a way that is easy to understand and interesting to learn. Please subscribe to my channel as I continue to post more videos and comment below on videos you'd like to see in the future. This is part 2 of a series I am doing on complex numbers. In part 1, I introduced the concept of imaginary numbers and showed how to perform basic operations on them. I'll leave a link to part 1 in the description if you haven't seen it yet and would like to check it out. In this video, I will be going over how imaginary numbers are used in the study of quadratic equations, and this is significant because quadratic equations are often used as an introduction to the concept of imaginary numbers in the first place. Quadratic equations are defined y equals ax squared plus bx plus c, where a is not equal to 0. For this video, I'm only going to use examples where a, b, and c are all real numbers only, since that is by far the most common. Here is a specific example of a quadratic equation and its graph. All quadratic equations have a vertex, and this is where the curve changes directions. Quadratic equations also have roots, and these are the x values for where the curve crosses the x-axis. This graph is an example of a quadratic equation curving upwards, and this happens when our a value is positive. As you can see, our a value is 5, which is positive. If the a value is negative, however, the quadratic equation will curve downwards. Though, as you can see in this example, there are still two clear places where the curve crosses the x-axis. When it comes to the amount of roots a quadratic equation appears to have, it is also possible for there to be one solution or even no visible solutions. This occurs when the vertex is above the x-axis and the graph curves upward, or when the vertex is below the x-axis and the graph curves downward. However, as it turns out, there may in fact be solutions where there seems there isn't, thanks to imaginary numbers. To find the roots of a quadratic equation, you must set it equal to 0 and then solve for x. To do this, we need the help of the quadratic formula, shown here. If you'd like to see me prove the quadratic formula, check out my video for it linked in the description. In the quadratic formula, the b squared minus 4ac term is called the discriminant. Because it is under the square root, the value of the discriminant is very important. If the discriminant is larger than 0, you'll find that there are two real solutions. If it is equal to 0, you'll find that there is one solution, and if it is less than 0, there are no solutions with real numbers. This is because when it is less than 0, then in the quadratic formula, you find that you are taking the square root of a negative number, and this leads to imaginary numbers. So the result is in terms of imaginary numbers. Let's try this with this specific example of a quadratic formula that appears to have no roots. Here we have our a, b, and c terms, and we can plug them into the quadratic equation. What we can do next is simplify the terms under the radical. We see that our discriminant, which is negative 4, is negative, and so we are taking the square root of a negative number. What we can do next is rewrite this so that we are taking the square root of negative 1, which, as explained in part 1, is I. Knowing the square root of 4, we have now simplified the radical into the simple expression 2i. Dividing 4 plus or minus 2i by 2 gives this as our final answer. And so, despite our roots not being visualized on this graph, there are still two roots, being 2 minus I and 2 plus I. Roots are the solutions that are meant to set the quadratic equation equal to 0, so now we can test this. I'll test for the solution 2 plus I and plug it into the equation as x. First, I'll distribute the 4 over the 2 plus I. And expanding this and simplifying gets 2 plus I squared minus 8 minus 4i plus 5, and seeing the two terms negative 8 and 5, we can combine these to get negative 3. So we are left with 2 plus I squared minus 4i minus 3. Next, what we are meant to do is to evaluate the squared term. Using the methods addressed in part 1, we can evaluate this using the FOIL method. And, knowing I squared is negative 1, we can just write that we are subtracting 1. Combining the 4 and negative 1, we are left with this. Notice that these terms cancel out, and these terms cancel out, leaving you with the desired solution, 0. We have now proved that this is the root, and if you tried evaluating this for 2 minus I, you'd get the same result. Feel free to try that on your own for extra practice with this concept. And so, we know that when our discriminant is less than 0, there are two specific solutions on the complex number plane in terms of imaginary numbers. And so, every quadratic equation has one or two roots, even though they may use complex numbers. And that brings us to the end of this video. Please subscribe to the channel and comment below on what you thought. Keep an eye out for future videos, and farewell for now.